Good morning, everyone. Today, in this session, we are going to discuss about the informed search algorithms. The last class, we discussed about uninformed search algorithms like DFS, BFS, uniform cost search, and others. In this session, I'm going to discuss about the informed search algorithms. This informed search algorithm contains an array of knowledge such as how far we are from the goal and path cost and how to reach to goal node. This knowledge helps agent to explore less to the search space and find more efficiently the goal node. The informed search algorithm is more useful when we have a large search space and it uses the idea of heuristic. So it is also called as the heuristic search algorithm. So let us discuss what is this heuristic function. Heuristic is a function which is used in informed search and it finds the most promising path. Generally, it takes the current state of the agent as its input and produces the estimation of how close agent is from the goal. And this heuristic method, however, might not always give the best solution, but it guarantees to find a solution in reasonable time. And this heuristic function estimates how close a state is to the goal. Generally, it is represented by h of n, and it calculates the cost of an optimal path between the pair of states. And remember, the value of the heuristic function is always positive. In coming to this admissibility of the heuristic function, it is given as h of n less than or equal to h star n, where this h of n is the heuristic cost and h star n is the estimated cost. So, hence, this heuristic cost should be always less than or equal to the estimated cost. So, when coming to this pure heuristic search or heuristic search, it is one of the simplest form of heuristic search algorithms, and it expands nodes based on the heuristic values. It maintains always two lists, that is open and closed. In the closed list, it places those nodes which have already expanded, and in the open list, it places nodes which have yet not been expanded. So, which we have already expanded, it will be always placed in the closed list, and which we need to further to be expanded, that will be maintained in the open list. So, coming to this informed search, generally we have two main algorithms under this heuristic search or informed search algorithms. That is, best first search algorithm are also called as the greedy search, or simply we call it as the greedy BFS. That is greedy best first search, and other one is the A star search algorithm. Before going to this two algorithms, let us discuss what is this heuristic in AI. And with the help of heuristic, let us solve one problem, that is 8 puzzle problem. Already we have seen how we are going to solve this 8 puzzle problem using the uninformed search. Today in this session, we'll discuss how we are going to solve the 8 puzzle problem with the help of a heuristic function. So already I told you this heuristic, it is nothing but a technique designed to solve a problem quickly. So we can say that this heuristic is nothing but the rule of thumb. We can also say that it is rule of thumb. Rule of thumb. So why we have to use the heuristic function? Already we got a solution using uninformed search, but why we have to use this heuristic function? Let us take the example of this 8 puzzle problem. In 8 puzzle problem, we know that the time complexity or space complexity is 0 order of b power d. That is, b is the branching factor and d is the depth of the tree. So when we construct this 8 puzzle using uninformed search, chances are there that it may reach to 3 power 20 for search space. And if it is 15 puzzle, then if we really get a solution, that the complexity may be 10 power 30. And if you think the 24 puzzle game you are implementing with a blind search or uninformed, it may reach to 10 power 24. Just think of how much space complexity and time complexity it is reaching. Means this all comes under one problem, that is non-polynomial, NP hard problem, okay, where we are unable to how much time and how much space it is going to take. But it gives optimal solution, but the time and space complexity is more. So to overcome this disadvantage, we come with an heuristic function. In heuristic function, we are going to find out the solution with the help of this heuristic function. For that, we use two distances. One is Euclidean distance and other one is the Manhattan distance. In Euclidean distance, suppose we have a start state and a goal state. We want to reach from start state to goal state. There may be many ways to reach to the goal state, but we are going to find out the distance between these two coordinates. Let us suppose say this is x1, y1 and this is x2, y2. So we are going to use a function Euclidean distance, that is x2 minus x1 whole square plus y2 minus y1 whole square. We will calculate the distance between two coordinates, and whichever is having the least distance, that path we are going to follow and we will reach to the goal state. In this way, we can reduce the time and space complexity of what we are facing with the blind search algorithms. And other one about this heuristic algorithm is we are going to use the Manhattan distance. Okay. So what is this Manhattan distance? With the help of one example of 8 puzzle, we will discuss. So let us discuss with this 8 puzzle. This is, we have two states. One is start state and one is a goal state. Let me draw this. So this is 1, 3, 2, 6, 5, 4, 8, 7. So this is our start state. This is our goal state. Now we are going to solve this 8 puzzle problem with the help of heuristic function. Normally, you know, with blind search or uninformed search, how we will go, reach the goal state. Now, with the help of heuristic function, let us see how we are going to reach to this. See here, this is the start state and this is the goal state. And when you see the position of the tiles, this Manhattan distance is by calculating the positions of the tiles. See, this 1 and 1 are in the same position, start and goal state, yes. So, it will be 0. Then, coming to this 2, it is one tile distance. That is, with if you move one tile this side, the 2 will be coming to the goal state. That means the value will be 1. One tile distance. Then similarly, 3 also. Only one tile away distance between these two. So for 3 also we can say it is 1. Then the next one is 4. 4 is two tiles away from the goal state. So now for 2, you can make it as 2. Then see, 5 in start state and goal state are at the same position. Now the value will be 0. Similarly, 6 in goal state it is here and in start state it is here. That is two-way distance. So it will be 2. Then coming to the 7 in start state here and goal state here, which is two-way distance. So we can make it as 2. And coming to the 8 in start state and goal state, it is same. So it will be 0. So when you calculate these values, 2 plus 2, 4 plus 2, 6, 8. So the heuristic function for this particular 8 puzzle problem is 8. This is one way of Manhattan distance to find the heuristic value. Other one is the misplaced tiles. With the help of this misplaced tiles also, we can find out the solution for a 8 puzzle problem. Now, see here, this 1 and 1 are at the same position, yes. So, you need not to count. But 3 and 3 are in not one position. So, that is one misplaced tile. 2 and 2 are not same position. That is one more misplaced tile. And 4 is not in same position. One more misplaced tile. 5 is in same position. So, we are not going to consider that. But whereas 6 is in different. So, other misplaced tile. 7 is not in the same position. Other misplaced tile. 8 in start state and goal state is at the same place. So, it is not in not misplaced tile. It is in the same position. So, we are not going to consider. So, heuristic value is 5 in this way if we calculate the heuristic function. So, here it is 8 when we make use of Manhattan distance. And if you use other technique of misplaced tiles, the heuristic value is h equal to 5. So this is how we are going to find out a solution to a 8 puzzle problem using the misplaced tiles. So why we have to use the heuristic function? What are the advantages when it comes to normal blind search? So, the one reason why, what is the importance of this heuristic function is, it always gives us the good solution. One reason why we use is, it always gives a good solution, but does not guarantee that it is an optimal solution. Okay, maybe it gives the good solution, but does not guarantee that it is going to give us the optimal solution. And if we want a solution quickly, if you want solution quickly, then we can make use of this heuristic function, and better in terms of time. Okay, within less time, if you want a solution, then we can use this heuristic function. These are the some of the reasons why we use this heuristic function for the problems or the disadvantages what we are facing with the uninformed search algorithms. Now let us solve one 8 puzzle problem with the help of this heuristic function, that is informed search, and we'll how we are going to find out the solution, we'll see. So here let us solve one problem. This is the start state. I'll mention here the start state and the goal state. So this is the start state and this is the goal state. Now let us solve this with a help of heuristic function. Let us make use of a technique of misplaced tiles here in this. Okay. See here, this is the start state, and see, let us first with the start state, we'll start what is the heuristic function, that is number of misplaced tiles. You see here, 1, 2, 3 are at the same position. 4 is not same position. So 1 misplaced tiles, 5 is not one position, 1 misplaced tiles, 6 is in the same position, 7 is in the same position, and 5 is not in the same position. That is one more misplaced. Uh, so we already done, and 8 is not in the same position. So total 3. So for the starting state, the heuristic function is 3. Now let us start applying actions. So here we can apply 3 actions, that is up, down, and the right. So once we apply the up, what is the resultant state? It is something this one. So 1 will come here, 2, sorry, 1, 2, 3, 4, 6, 7, 5, 8. And here the next one, when we make an action of down, the resultant state is 1, 2, 3, 7, 4, 6, 5, 8. And if you make an action of right, the resultant state is 1, 2, 3, here 4, 6, 7, 5, 8. Now similarly, find out the heuristic value of all these resultant states. So just number of misplaced tiles you calculate, it will be 4. It is also 4. It is 2. So now we need not to explore these two. Where we got the heuristic value 2, then you explore only this particular state. Why? Because we have heuristic value equal to 2. Now you can make it as we'll get 4 actions, that is up, down, left, and right. Okay. So here, so with the up, down, left, and right, you will again calculate the heuristic value of each and everything, and whichever is having the heuristic value less, again you explore that state, At this some point, you are going to reach to the goal state. In this way, we are reducing the time and space complexity of what we have faced in the uninformed search algorithms. So I hope you understood. Please further you expand this and try to find out the solution and try to reach to the goal state. Because of this time constraint, I'm not expanding these states, but I hope you understood the concept of this heuristic function, how we are going to solve the 8 puzzle problem. Thank you.